welcome back. So today we will keep solving the problem. But I find the problem is getting difficult. So up to now so from now on I will separate the video into maybe one video only solve 2 to 3 problems. Okay, so let's see 53. So you know that the f and g is continuous, and then you know g is at least 3 times continuous differentiable. Y is greatest integer n, for which f must be n times continuous differentiable. So basically this question is we need to use the Leibniz formula. So basically when you have f, x, and t, you do the derivative. You just plug the t term into b of x and do the integral for do the differentiation on b. Then you minus a part and you add the partial derivative term. So once we have this, then we can plug in the formula. So g prime of x is only plug in the f of x at the y term. So this term is 0. And also another term is 0 because 0 derivative is 0. And plus the negative minus y term. Let me shrink. Okay. So we have this. And then we do the second derivative again. And then we do a third derivative again. Since we know that g is 3 times 3 times continuous differentiable. So f prime is only 1 times, can at least need to be 1 times continuously differentiable. So we choose A. X is a real number randomly chosen from 0, 3, and y is a number randomly chosen from the 0, 4. And what is the probability that x smaller than y? So basically this is a probability problem. This is x, this is y. And this is the region. And we need y larger than x. So this region is the region y larger than x. So the area of this region is 1 plus 4 times 3 divided by 2. So it's 15 over 2. And the whole region is 12. So the probability is just 15 over 2 and over 12. Okay, so it's 5 over 8. We choose C. Okay, I think I will solve 55. A, B are positive numbers. What is the value of this one? So remember to solve this, you just first write it as a fraction term. And there's a minus sign. Then we do the first term. Okay. Okay, we do the first term. how do we do this term? How do we do this term? We just use ax equals to u. Okay, maybe we don't need this. We times negative exponential minus ax dx. So notice that this term is equals to d exponential minus ax plus 1, and then minus 1 over a. So this term can be written as this. So this is minus a log and the infinity 0. When you plug infinity, since a is positive, so this term is minus a log 1 plus 1 over a, and x0 is log 2. So this term only 1 over a times log 2. So when you plug it back, the total answer is 1 over a log 2 minus 1 over b log 2. Let me see. I missed some minus sign here. Where is it? Where is the minus sign? I miss. A log 2. Oh, so this is minus a log 2 plus. So this answer is b minus a. A b. Yes. So we choose E. Be sure to subscribe to my channel